just a C. This is an AB type motion. And remember, the only thing that's going to happen here is instead of being at straight on or at 45, it's going to be something in between. It's going to be this sort of thing. So AB is really not terribly different from the others. This one is kind of looking that way though. But anyway, here's one that's pretty close to the axis. Okay. Here's one that's pretty close to the slow axis. You see it making a circle. Is it? Looks a little weird, doesn't it? Is that right? I'm going to go out here in the middle of nowhere and see what it does. What we should be getting is something that's on the crank that looks like that. I guess this is, I'm looking at it at an angle. Yeah, no, I see. Those are circles, and there are circles around this guy. There's the omega axis, crank axis, right there. So this one has a crank pretty close to the A axis.
Stereo pairs really help there.
What we need to do would be increase that a little bit. And that you can do. Let's just take a look and see how you do that. I'm going to bring the speed down here before we do that though, to about 1. By the way, you can go backwards if you want to on these things. That's a minus time. Try to get it on the 1. There we go. Okay, controls. Let's see if we can get the B coefficient up just a bit here. It's at minus 0.2. Let's take her over to maybe minus 1 to see what the heck that does. Okay, reset T equals 0. Okay, so omega, it's
off the screen.
Into the board. You can see what's going on here. It's making a circle around that omega. Now I can go ahead and start it off, on this axis here. See what it does. And now it's making a circle around plus omega. It was making a circle around minus omega before. And by the way, you can see the components of that spin vector oscillating on the respective axes.
That'll be enhanced in the very near future with projection lines as well. You'll have a choice there.
You can turn that on, and then you can see the thing.
And stereo pair.
Yeah.
That's my next target.
Stereo
right
pair really helps for the three-dimensional space. No doubt about it.
Even this
anyway, here's a mode, right? That's a normal mode. And the spin vector is on the back side of the omega vector. And then going on the front side of the omega vector is this one. There's a spin vector on the front side, nearly. Okay.
You're perfect.
So it's really, this one, unlike what we're going to see with the C, this one is just a rotation of A or B. B is at 45. 45 is bilateral symmetry. It splits the difference perfectly between the two axes, right? And then there's something that splits it imperfectly, okay? And that's the ADB mixture, okay? And it's nothing but this turn, you see. It's when you mix the C in that
it'll travel from
you get the crazy
one
ellipses.
latitude to another latitude and back and forth.
Yes, yes. And in the process it makes ellipses. You see, everything that has to do with A and B, which is this equator here, is neither right-handed nor left-handed. it's standing. It's like a standing wave. It doesn't have any current. But everything here is right-handed ellipses of some kind, and everything over here is left-handed ellipses of some orientation and shape. So the real complexity is in the vast neighborhoods that are off the equator of the C axis. The C is the one that makes things crazy. C for crazy, that's another thing that begins with C. It's that circular cyclotron, centrifugal Coriolis, current carrying complex, blah, blah, blah. Okay, is that making some sense?
It is.
Yeah. Okay, so we'll come back and hit that one first next time. And then we'll do AB again over, look at how it makes hyperbolas and stuff like that as far as its eigenvalues go. And that's beginning relativity right there, right? So those two hyperbolas are mass shells. But no one would think of that, but well, we're just playing with these two oscillators.
Hyperbolas in terms of like the
When you
energy
plot the
levels.
energy, when you plot the eigenvalue as a function of, say, B, while you've got a certain AD.
Next lecture.
We'll talk about that. That's going to take some time. I figure
It's in this one a little.
it's really worth looking at that carefully. You might want to go ahead and study it. It's, you know, on this particular lecture, so it's already out there. Take a look at it so you have a heads up, so to speak, on what's going to happen. You can just try them out yourself. It is quite remarkable, and that's how the maser got invented. The invention of the maser involves a C and an A mixture, basically, or a C and a B mixture, one way to say it. And actually can be reduced to an A and a B mixture, which is ADB mixture like that. It can be reduced to that. But in the case of ammonia, there was actually a C involved. Okay?
Okay.